Hello, future network associates. This is Whale Hater doing Packet Tracer 10, 2, 2, and 3. This is Troubleshooting Single Area OSPF, version 2, by the way. Now, what we're doing is finding out through show commands and pinging what in the world is going on. Now, one of the things you'll find is that PC3 can't ping anybody. And I'm sure that you found some of the problems, but how do we find the solutions? So one of the things that you'll find, we'll just go through the problems real quick. So PC3 can't ping anybody, and you'll find because there's no neighbor adjacencies on here. The second thing you'll find is once you get the neighbor adjacencies up for R2, and also, let's see, yeah, R2, you can send traffic across the way, and you can ping PC1. So your pings are successful because it's going to go through R2 to R1, but it's not going to go through the shortest path, which would be serial, whatever the serial link is. And that's because if you use a trace route, you're going to see it go this way versus just straight across, which would be better. And that's because it does not have a neighbor adjacency with R1. Now, why does it not have a neighbor adjacency? Well, we'll figure that out. The last thing you're going to find is when you're going through and pinging everybody, all the devices will finally ping each other, but you can't ping the web server. Now, why is that? Again, we'll get there. So first things first, R3 does not have any neighbor adjacencies. Let's figure out why. One of the best show commands that you can use for OSPF is show IP OSPF interfaces, and that's going to show everything that is configured with OSPF, and then all the details accordingly. So what we find here is gigabit Ethernet 00. That's for the LAN. It's up and working. Everything's fine. Then you've got your serial 00 interface, and I believe that one is to R1. Could be wrong though. And then you're going to find here on serial 001, I believe that one is to R2, that is not configured correctly. Now, why do I know that? Well, the neighbor adjacency is down, so something's up. But you also see here that hello timer on gigabit Ethernet 00 is in the default of 10, as is the serial link over here. But the serial link going to R2 has a hello timer of 20. Now, if those don't match, no adjacencies will happen. So let's configure that properly. Configuration terminal interface 001 IP OSPF hello interval. So that's going to change it to 10. Enter. Now just give it a couple seconds and we're going to get that neighbor adjacency up and running. Now we've already got our points, and there it is. There's our neighbor adjacency with 10.222, which was be router 2. We're going to go to end, show IP OSPF neighbors. So now we've got a neighbor. Now we're missing one. We want R1 too. Now what you'll find there is the reason why he's not becoming a neighbor of R3 is because he's sharing the wrong information here. So I'll show you with a show run command. Just go down to the bottom here. We have a router OSPF 1, that's right, and we have all these network statements. Now those network statements are correct. On our 1, well, you'll see here it says, let's see, 192.168.10.4.003. That's that guy right there. That's being shared about and to. On R1 though, what am I doing? Show run. Spacebar down to the bottom. You'll see here that it's got some network statements as well. But this last one right here is incorrectly configured. Okay, so it's not sharing with or to this network line. It's configured as 172.16. This is a 192.168. Now the rest of this is all correct. We want to keep this. We want to get rid of the rest. Let's just do a copy paste, because that is easy peasy, lemon squeezy. All right, enter, enable, configuration terminal, router, OSPF, process ID of 1. Now, just for best practices, let's delete this one route, this network statement out of there, because it's just sloppy otherwise. So we'll press the paste button, and then we're going to arrow over and say no. So it deletes it. Now let's do an up arrow. And all we have to do here, everything else is correct. Let's just make that an 8 there, 168, and we'll change the 7 to a 9. So 192, 168, 10, 4, and then the wildcard mask of the /30. Let's go over here and delete the no, because we want to enter it in. Enter. Again, we're going to get our points down here and give it a couple seconds, and we're going to find that neighbor adjacency with R3 is up. 333. We're ready to go. So everything else is configured properly except for one thing, like I talked to you about before. All of these PCs now are going to ping each other just fine. Everything's going to be working wonderfully on this private network. But once we try to get out to the internet, that's when the problems happen. Our PC2 is going to be able to get there just fine. Why? Let's look at that. Enter, show IP route. Right now, if you show the IP route, we're going to have a default route to the internet going to web server. So this router knows exactly what to do with any traffic going to a network it doesn't know about. Dump it to the internet. That's right. But does R1 know about that? Does R3 know about that? No, they don't. Show IP route. So we've got all the other OSPF networks. We've got directly connected networks and everything, but we don't have a default route to the internet. Why is that? Well, it looks like if we go back to R2, it looks like one's been configured, but is it being shared? Show run. We can also, I like using the show run command because it's simple, but we can also do it this way too. Show IP, let's see, show IP protocols. Let's see. Nowhere in here does it say that it's sharing default routes. Okay, it's not saying that. Nor if we look, I'm just cycling up, and we're looking at that show run command now. Neither is there a default information originate command given in here. So the default information originate command tells the router to share the default information to an internet address. So this, let's see, I'm going to cycle up again. This is a default route, so that would be default information to be shared. Candidate for a default, see, little address. So going back down, cycling down. Configure terminal router OSPF, process ID of 1. Now let's give it the default information originate command, and we'll hit enter. We're going to get our, we're going to get our 100 points right straight away. And let's just fast forward time just a little bit, and we can also minimize R2. And notice here we're on R1. This is the old routing table. Let's see if anything new happened. We're going to press our up arrow, enter. Look at that. We got a brand new spanking route. This one, again, is learned through OSPF. So it was learned through OSPF from router 2. It is a candidate for a default route. Okay, because it got that triple or quad 0. But what does this mean, this E2? Well, E1 or E2, all it means is it was externally learned by OSPF. So we've got these two definitions up here. So what that means is it was put in by either EIGRP, RIP, ISIS, any of these other routing protocols, and OSPF picked it up and said, hey, let's use it. But right as we know, this actually was a static route put in by some administrator somewhere. But again, it's externally learned by OSPF, and that's all that means. Well, that is the packet tracer. You guys can go through and make sure all the pings work. If they don't, let me know. I must have messed something up, because you guys are awesome and wouldn't make such stupid mistakes as I do. If you haven't subscribed already, please do so. Thank you very much for all those who have. If you have any questions, again, put them in the comments section below. And you guys are always awesome. So I'm going to give you this one last thought. Peace.